Edison and Swan tested all kinds of different materials for their filaments, everything from raw silk and parchment to cork. Edison even tested his engineer's beard hair. Eventually, he settled on bamboo fibre, while Swan used a treated cotton thread. Edison and Swan's light bulb designs were very similar. Eventually, they came to an agreement and went into partnership to sell light bulbs in the UK. Today, many people still believe that Edison alone invented the light bulb, while Swan has become a footnote in history. But his incandescent bulb was only part of Edison's strategy. He'd also invented an entire electrical system of sockets, cables and meters to go with it. And being a brilliant businessman, he'd developed a groundbreaking new way of distributing electricity. Edison knew that the key to making money from his system was to generate the electricity in a central station and then sell it to as many customers as possible. It seems obvious to us now, but until then, anyone who wanted to use electricity had to have their own noisy generator to make it. Edison's ambition was huge. He wanted to light the fastest growing and most exciting city in the world. New York. In the summer of 1882, Edison stood in a unique position at the center of 19th century science and invention. He'd patented a cutting-edge incandescent light bulb. He'd amassed an unprecedented knowledge of electrical engineering. And above all, he'd cultivated a reputation among the American public of being such a genius inventor that journalists hung on his every word. And the financial muscle of Wall Street was quick to throw itself behind his new ideas. His vision to electrify Manhattan, and then of course the rest of the world, was seemingly within his grasp. Because Edison and his team were about to launch their most expensive and risky project yet. America's first power station generating continuous direct current. Just before 3 p.m. on the 4th of September 1882, Thomas Edison, surrounded by a gaggle of bankers, dignitaries and reporters, entered J.P. Morgan's building right behind me, flicked one of the Edison patented switches, and 100 of his incandescent bulbs began to glow. Turning to a nearby journalist, he said, "I have accomplished all that I've promised." Half a mile away on Pearl Street, Edison's new power station, costing $500,000 and 4 years of hard work, had sprung into life. The current surged through buried cables, stretching out in each direction. Of course, it might seem obvious to us now, but in New York back in the early 1880s, the idea of burying electric cables underground seemed like an unnecessary expense. This street would have been crisscrossed with hundreds of cables used for telegraphs, telephones, and arc street lighting. Looking up, you'd have seen a tangled mass of black spaghetti blocking out the light. Edison knew this dangerous situation had to change, and for him to make as much money as he could, electricity needed rebranding. It had to be considered safe.
So Edison is arguing both for the greater safety of his DC low voltage system and for underground lines. He can argue that he has a much safer system than electric arc light for streets or gas lighting for indoor lighting, right? He doesn't have to worry about fires, doesn't have to worry about electrocution, that all of this is much safer because of the system he's created with this underground system.
Burying every cable was not only very expensive, but was a logistical nightmare, because this was one of the busiest square miles in the world. Edison chose this area for a reason. Wall Street. Rich, important, influential. Because for Edison's system to make money, all these wealthy customers had to be within a mile of his power station. And this was because Edison calculated the thickest cable he could afford would only carry an adequate amount of his continuous direct current to customers within this range. This was a huge leap forward, because for the first time, dozens of customers could be supplied by just one power station. But there was a big problem. Edison's network could never be economical in lighting America's new suburbs. They just didn't have the concentration of customers needed to make building these expensive power stations worthwhile. Had we stuck with Edison's way of generating and distributing electricity, the world would be a very different place. We'd have to have power stations scattered around no more than a mile apart, even in the centres of our towns and cities. And it would be extraordinarily expensive to even provide power for smaller communities. But someone who held the answers to these problems was about to enter the story. Someone who would help create the modern world and who'd play an integral part in one of the biggest fallouts in scientific history. His name was Nikola Tesla, and he was right under Edison's nose. Nikola Tesla was a Serbian inventor who was born in Croatia and who worked for Edison briefly after arriving in New York at the age of 28. European, introverted, a deep thinker. He was everything Edison wasn't.
Edison and Tesla could not be more different in the way that they handled their self-appearance and their manners, and the way that they constructed a public image for themselves. Edison could care less about the clothes that he had on, and if he spilled chemicals on his good Sunday suit, then he spilled chemicals on his good Sunday suit. He was, basically a very, very kind of slovenly guy. Tesla, on the other hand, even as a young man in his mid-20s, is thinking about his appearance, how he comes across to people, so he cares about his clothes, he cares about his manner, indeed he even cares about how his portraits are taken, and he always wants to make sure that he has a nice three-quarter profile, so you don't see the fact that he has a bit of a pointy chin.
The life and death of Nikola Tesla is one of the most fascinating yet tragic stories of scientific brilliance, cutthroat business, and shocking public relations stunts. The American public may have been wowed by Edison's new direct current power stations, but Tesla was less impressed. He had a dream electricity could be transmitted across entire cities, or even nations. And he believed he knew how it could be done, by using a different type of electric current. Electrical experts knew that the smaller the current sent down a cable, the smaller the losses in it through resistance, and so the longer the cable could be. Tesla proposed using a method of transmitting electricity where the currents could be lowered without a fall in the amount of electrical power at the other end. It was called alternating current. Alternating current is exactly that. It's an electric current that alternates between moving in one direction, then the opposite direction very quickly, as opposed to a direct current which moves only in one direction.
Tesla was interested in alternating current because, like other electrical engineers in the late 1880s, he realized that as you raise the voltage of any current that you transmit from point A to point B, it's going to be more efficient to have a higher voltage.
And since the amount of electric power in a cable is its voltage multiplied by its current, increasing the voltage meant the current in the cables could be reduced, and so losses due to resistance would be less.
However, you don't want very high voltages on the order of, say, 20,000 volts coming into your home. So you need to step down the current that is being transmitted over a distance into your home, and to do that you need a converter or a transformer. Alternating current allows you to use a transformer to make that switch from the high transmission voltage to the lower voltage that you're going to use at consumption.
Perfecting the technology to transmit electricity hundreds of miles from where it was generated would mark a huge step towards the modern world. And a wealthy industrial entrepreneur was already developing the solution. His name was George Westinghouse. Westinghouse believed alternating current was the future, but it had a big drawback. While it was fine for electric light, unlike direct current, there was no practical motor that could run on it, and no one believed there ever would be, apart from Nikola Tesla.
Tesla, as an inventor, liked to say that the first thing you need to do is not to build something, but to imagine it, to think it through, to plan it. And he had what modern-day psychologists would call an eidetic memory. He could basically remember everything that he saw and then visualize it in 3 dimensions. And they often say that the people that have this skill see it about an arm's length away out here, and they see it in 3 dimensions in that space. And all of the indications are is Tesla had that ability.
This is a Tesla egg. It's a replica of the one Tesla used to demonstrate his greatest breakthrough and one of the most important inventions of all time. It showed how rotary movement can be produced directly from an alternating current, crucially one that could be generated thousands of miles away. This was something that had never been done before.
When Tesla was working on the alternating current motor, he was thinking big, and he was not just tinkering with one little component of the motor and saying, gee, if I can make that a little bit better, it will work out. He's actually thinking about an entire system that involves the generator, the wires to the motor, and the motor itself. He's a complete maverick. He's thinking outside the box. He's doing things very differently than any of his fellow contemporary inventors.
Tesla's solution was ingenious. He fed more than one alternating current into his motor and timed them so that they followed in sequence with each other. The first alternating current energized a coil of wire inside the motor, creating an electromagnetic field which attracted the motor's central moving part to it and then faded. The second overlapping current fed the next coil, dragging the moving part around further before it faded, and the same for the third coil and the fourth. The result was a revolving magnetic field strong enough to make the motor, or in this case his egg, spin. Tesla designed an entire electrical system around this, called polyphase transmission. This meant a noisy and smelly power station generating lots of useful alternating current could now be situated away from populated areas.
And for the first time, you can build large power stations wherever you want, on the edge of town or at a waterfall like Niagara, and you can then distribute the power over long distances and serve all the people in a major city or metropolitan center.
Tesla's breakthrough was the last piece of the jigsaw, but he still had to convince the world that his solution was better than the direct current method championed by Edison. Edison continued to roll out his direct current system, building power stations across New York State. But then Tesla met George Westinghouse, the man who could make his dreams into a reality. In July 1888, Westinghouse made an offer for Tesla's patents, which has become part of the mystery and folklore surrounding the whole Nikola Tesla story, where it's difficult to separate fact from fiction. Tesla was paid $75,000 for his alternating current patents and offered $2.50 for every horsepower his motors would generate. This should have guaranteed him vast wealth for the rest of his life. But that isn't what happened.